Welcome back to Science Matters. Now we've learned what to eat, we've learned how to move, and now we're going to learn how to talk. Joining me here today is Dr. Jeffrey Jones, who is a professor in the Department of Psychology at Wilfrid Laurier University. And Jeffrey is going to teach me how to run through one of his experiments that he often uses with children and other members of the community. And we're going to see how this all works. So Jeffrey, walk me through the process.
Absolutely. So what we're interested in is basically trying to understand how the brain learns to produce speech. Speech itself is an extremely difficult task. It's extremely complicated. So when we're born with this vocal tract that we really don't know how to use. And what kids do is they start making random sounds, and we call this babbling. They start ga, ga, ba, ba. And what they're doing is learning how to control these very complex articulators in the mouth. So the larynx, the vocal folds, the jaw, the tongue, the lips, the velum, they all have to be coordinated with precise timing. And this is an incredibly difficult task. So what kids are doing when they are going through this babbling stage is they're actually just making these random motor movements and listening to what comes out. And over time, what they do is they build a map between the motor system, so how they produce sounds, and the motor commands involved with that, and what the sounds are that result from those motor movements. And all children are born within a language context. So at the beginning, they can produce pretty much any sound, but over time, they start paring down the number of sounds they're able to produce based on the language context. So what I'm going to get you to do is put on these headphones. And when you put on the headphones, I want you to sing a note. I want you to hold it for, say, 5 seconds. You're good. No, you're good. So what you have done, which is relatively rare. Are you a singer? Like, have you ever been in a choir, for instance? Okay, so you are one of the participants or one of the subjects that we do research on. So we do some research on singers. And singers have an ability to ignore some of this auditory feedback. And the reason they have this ability is because they've been vocally trained to use the motor system and sort of avoid incorporating some of the auditory feedback. So for instance, if you're singing in the choir and you're hearing someone else's voice who's singing the same pitch as you want to avoid listening to them and incorporating them into your own motor control. And singers learn to do this. Non-singers can't do what you just did. What they would do is they would compensate for some of the changes. So what we did is, Nikki in the booth, she shifted your voice, the sound of your voice, the pitch of your voice, just slightly, so she maybe shifted it up. And what people normally do is they'll compensate by unconsciously shifting their voice down. And singers can avoid doing this because they are relying exclusively on the motor commands, what we call feed-forward control. They're not incorporating the feedback. And this comes as a result of training. And we're interested in studying singers to understand how this training affects this sensory motor control of speech. Because a lot of communication disorders might be linked to a disruption in the processing of this sensory feedback control. So for instance, stuttering. One of the hypotheses for why people stutter is they're either paying too much attention to this auditory feedback, and it's leading to what you may have experienced with the delayed auditory feedback that we gave you, where you were a little slow. You're pretty good, so you're a really good speaker. If you put the headphones on me, I'm not the greatest speaker. I will start stuttering. It will sound like a person who stutters. So stuttering is one potential disorder. Another potential disorder are the problems that people who suffer from Parkinson's. So in Parkinson's, there is a gradual tendency as the disease progresses progresses for their speech to be severely affected. So they start getting very quiet voices, and they start having a monotone voice. Now, the amplitude of your voice, as well as the pitch of your voice, is very controlled by real-time feedback versus things such as formants, the resonances in the vocal tract that allow us to perceive vowels. So the difference between an ah and e is due to what's called a formant. Those are a little more resistant and a little more feed-forward control. We rely mostly on our motor commands, and we use the feedback to fix any errors that happen, but the errors are fixed in the future. And the reason that we don't use it so much for formants is because they go by really quickly. So, it's very difficult to use feedback in real time because it takes a fair amount of time for the ear to process the sound, and then some comparator has to compare what we expected to what actually happened, and then the corrections for that the motor system has to do online has to happen. And that takes on the order of 80 milliseconds, and that's way too slow for us to use feedback in real time. So the real role for feedback in most speech is to correct for errors in the future, and that's how children learn to speak. We do need to build up these long-term maps for instance, pitch, if people speak a tone language such as Mandarin or Cantonese or Thai. That's a different scenario. So language has a huge impact on how we control these certain aspects of our speech with sensory feedback.
So from the nutritional chemistry of what we eat to the neural mechanisms behind movement and communication, the study of human health is a complex and diverse field. To find out more about how you can participate in Dr. Jones's research on speech and communication, visit joneslab.ca for more details. To find out more about today's episode of Science Matters, you can check out our website or send me a personal tweet at Alethea Zilli. That's it for today's episode of Science Matters on Rogers TV. Thanks for tuning in.